Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem Smith number. So, now let us discuss what this problem is all about. This problem is asking us to tell us that if a number is a Smith number or not. And when a number would be Smith number? A number would be a Smith number when it is a composite number. Okay, what do you mean by composite number? All the non-prime numbers are composite numbers. It has more factors than 2. Okay, and the sum of the digits of the given number should be equal to the sum of the digits of the prime factors. Okay, this is what is asked. Now, let us first understand what is asked. Given a number n, okay, and the n value is still 10 to the power 5, a small thing to notice, but yes, it should be noticed. Now moving forward, we first need to check, like, to confirm if it is a Smith number or not. We first need to check if it is a composite number or not. That is checking for prime, and we already know an algorithm where we can check a number if it is prime number or not in square root of n. Square root of n, this is what we can do. Now, sum of the digits of the number n. Sum of the digits, taking out sum of the digits is also very easy. How? Like, let's say we have 386. So to take out the last digit, what we would do is 386 divided by 10, which is equals to 6. Then 386, we would say that at this point, we would divide it by 10, the integer division. After doing the integer division, it would be left with 38. Now again modulo 10, which would again give me 8. Again, doing the integer division by 10, we would be getting 3. Again modulo 10, which is equals to 3. Again divided by 3, which is equals to 0. So we can see that by doing 2 operation each time multiplied by the number of digits, we can get the sum of the digits. And the value can at max be 10 to the power 5. So we need to number of operation needed would be 6 elements at max, multiplied by 2, because 1 for bringing out the modulo, 1 for dividing it. So in 12 operation, we can find out the sum of the digits. Okay, so sum of the digits is also done. Now finding out the prime factors. Finding out the prime factors is also very easy. How? Let's say we have something like 15. So what we can do is we can start working from 2. 2 can divide 15. No. 3 can divide 15. Yes. So we would divide 15 by 3, which would be equal to 5. And then 4 can divide 15. No. 5 can divide 15. Yes. So again we would divide. This is how all the numbers which can divide the number, we would keep dividing it, and they would contribute as the prime factors, and that would be done. And this is again, taking out the prime factors is again square root of n, and sum of the digits is the same. So now let us just implement what a function known as is prime, which would just check if a number is a prime or not. Let's just implement sum of the digits, which would just bring out the sum of the digits. The third part is that we would just build up or to find out all the prime factors, and that is done. So finding out prime factors, checking if a number is prime or not, and sum of the digits. These are the 3 functions you would require. That would be done. Now let's just move forward to the implementation. So now I would just implement int sum of the digits and int n. So now I would say int initially the sum is equals to 0, as I have shown you. While n is greater than 0, we would keep doing it. So sum plus equals to n modulo 10, and then n is equal to n divided by 10, writing out the shorthand of it. Now the very next step is to write a function which would check if it is a prime number or not. So we would just say bool is prime, and we would give it a number n. We would handle the corner cases, that if n is less than equal to 1, If n is less than equal to 1, return false. Now we would start moving from I is equals to 2, I is less than equal to square root of n and I plus plus. At this point we would say if n modulo I, if it is equal to 0, like if we are able to find any number which can divide the given number other than himself or 1, then we would say it is a false. If till the end we were not able to find a flaw, we would simply say return 0, return true, that it is a prime number. Now the very next step is finding out the sum of the digits of the prime factor. So we would say int SOD of what? Prime factors. Okay, and we would just give it a value n, and then we would start the sum. Int sum is equals to 0. Done. So now we would start doing it. For int I is equals to 2, I is less than equal to square root of the value n, and then I plus plus, and then we would say while n modulo I, if it is equal to 0, then we would say sum plus equals to sum of the digits of this particular factor. Okay, and then keep dividing the number, like n divided by equal to I, n is equals to n divided by I. Okay, at the end, okay, if the given number is greater than 1, okay, then sum plus equals to sum of the digits of the given number n. Okay, it's done. Okay, so we have bull is prime, sum of the prime factors, and then this thing. Now let us code the last statement. But if it is a prime value, if it is a prime value, then it is not possible because the first condition is void. Else we would simply return that if sum of the digits of the given value, if it is equal to sum of the digits of the prime factor, sum of the digits of the prime factor, then return accordingly. If this would return true, the function would return true. If this would return false, the function would return false. Okay, seems correct for the sample test cases. Now let us see for the complete test cases. Okay, seems an issue with the code. I didn't really return the sum. I just saw it at this point. If int sum plus, so I didn't return the sum at any point. Yep, so I should return the sum. Let us just see again. And yes, it's done. So I just forgot the return thing. So I just saw it when I was just going through this in just a sec. So that's it from my side. Thank you, everyone.